12, confidence interval versus point estimation.
And this is my student. This is my student. Everybody say hi.
Hi.
Yeah, if I forget about you guys, I can go to the my videos. Oh, them. Yeah, them. Okay. Now, when we want to talk about this, we already talked about triplet. Why we need to talk about them more? Because I love you guys so much, so don't want to let you grow up too fast. That's why more chapters is better, right? Okay. Now, when we do the hypothesis test, our goal is to estimate the population, right? Remember, our hypothesis always say mu, 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 mu. Right? You compare two samples, and you assume the two populations, they also look like this. Okay, but it's really hard to really predict, right? So you need to predict, either use their point estimate, use 1 point, you use their mean score, or their mean of difference, okay, or the difference of mean to predict. And when you predict, you just predict a range. A range, okay? And so, the first step when you prediction, you use point estimate. Okay, point estimate. And that is a definition of point estimate. It's a single value, okay, based on sample data that is used to estimate the parameter of the population. So use the mean of your sample to predict what is the mean of the population. Okay? And of course, they will have a 3 here. Okay? Look at this 3. And I will show this step when we are in the your turn. But those 3, when you're doing one sample T, your point estimate starting from your mean score. Okay? So here say mean, right? So that be your M. When you do 2 sample independent, your point estimate is mu1 subtract mu2. Right? But you don't really know mu1. You don't really know mu1. You don't know mu2. You only know mean 1 and mean 2. So your point estimate is mean 1 subtract mean 2. Okay. When you do the dependent T, your point estimate is what? Is what? It's a mu D, right? It's mu D, and you use MD. Okay, so that makes sense, right? So your point estimate, your starting point. So when you do this chapter, the first thing they ask you about estimate point. So if you are doing one sample T, you use what? Use M. If you use 2 sample T, use independent T, use M1 subtract M2. If you use a dependent T, use what? MD. Okay? Okay? Now, when we do second step is confidence interval. Okay? Then you use that starting point. Now you have to see a range. So actually, if you pay attention, actually when we run our SPSS, they already give you confidence interval. They already give you there. Okay, so now we just learn how to calculate. Okay, learn how to calculate. Okay, and the reason we want to use confidence interval, because what? Because it's no way when you use point estimate, just say, okay, because my mean score I got it from this, my sample is 96. So that means population, your mean score is 96. How do you know? Right? So you say, oh, maybe between what and what? But also you need to know, are you looking for 95% or 99% confidence interval? Okay, is anybody can, like, before I tell you, can you kind of relate 95% and 99% to our alpha level? How they related?
0.05 and 0.01.
This is 0.05. This is 0.01.
Yes, ma'am.
Okay, and remember our normal distribution. So I want to see the confidence interval in this big range or a little bit smaller range, right? Depend on how big range you want to open. Okay, so this is the confidence interval. Okay, and okay, then this is the formula. Okay, remember LL and UL. What's LL?
Lower limit.
Lower limit and upper limit. But this time not just subtract 0.0, not subtract 0.05. Okay, not just like that. You have a formula. Okay, now I want to remind you, T here. Okay, let's guess. Is T in this formula is T obtained or T critical? Let's guess.
Critical.
You say, I heard two. I heard both. Is T critical or T obtained?
No, I'm gonna switch and say T credit.
Don't switch.
I'm not that smart.
Yeah. It says obtained, right?
Huh?
It says obtained.
Oh, yeah. Okay, I'm going back. T obtained.
You say T obtained?
Yeah. Context clues. It says obtained.
Wrong.
Wrong.
Critical. Okay, so
Oh.
if you are calculate T obtained, don't put there, okay? Because we use T critical to predict, okay? And this T critical, that's why we put 95% or 99%. So that means when you see 99%, you get a T critical from 0.01. Okay? When you are 95%, use 0.05. Okay, that's why the level is very important. Otherwise, when you put the wrong number, they don't make sense. Okay, okay, because you are predicting, so you don't use the original. You already got your T-score there. Okay, so what do? You use the estimate point. That's why they say obtain sample statistics, that your estimate point. Okay. And minus, because remember, this actually all two tail. So you have negative positive already, your critical value, okay? Don't use subtract negative become positive. Okay. When you are subtract, just use your T critical, already have a positive negative. So just do the same thing, one is subtract, one is plus. Okay. We have example, so I'm just going to give you this. Okay. So this more detail. Okay. So if you are doing one sample T, this is your point estimate. Okay, this is your point estimate. Okay, and then subtract T. Okay, now you also make sure you have SM, standard error. Okay, minus or plus. So and this T is critical. Okay, but you have to calculate your SM. You need to calculate SM. Okay, if you are doing independent T, you mu1, M1 subtract M2, okay? And then you use your T critical and then times this. So you still need to work on this. You still need to calculate this. Okay, this will exactly the same as your chapter 9, 10, 11, okay? And then if you do the dependent T, use MD subtract T SMD, SMD. Okay? So all the things you work for the first chapter 9, 10, 11, you don't waste your time because they take you to here. Take you here. So actually in our your turn, we will see, actually let us repeat those questions, similar questions, and then ask us to calculate this. Okay? Good? Okay? And then we say it's 95%, that's also mean 0.5, and the two-tail, and 99%, and that's mean 1%, and that's two-tail. Okay? Okay. Oh, looks like I forget to fly, so everything will be there. I don't know. Okay, so look at this. So I just use your turn so we can save the time. Okay, so first one, the history professor was curious about knowledge of history of graduating senior in her state. She thus have a 100-item history test to random sample 75 graduate senior with a resulting M equals 72, SS equals 7,400. Okay, so the first thing, so let's make a point estimate. Okay, point estimate, since already there, looks like I don't have any secret here. Okay, so you can see your point estimate is 72. Okay, so you know where 72 from, right? From there. Okay, now after that, then let's say that's estimate 99% of confidence interval, so that you already think it's alpha level 0.01. Okay, so alpha level 0.01, then first of all, you should get your T critical out of your hand. Okay, so degree of freedom 74, why? Because 75 people. Okay, and 74, and then T critical is positive, negative 2.660. Okay, so this step, you know how to do it. Then, in your formula, you need all this, right? You need this, so you need to get your S, because you need to get SM. Okay, so they give you SS. So you put SS there to get your S. Right? And then from there you get your standard error, SM. Okay? Then you plug in. Okay? Just very, 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 very important, remember, is this. Okay? T critical, T critical. Because chances are when you get here, you can say, oh, I'm going to calculate T of 10. And you maybe have tendency to put T of 10 there, but no, T critical. Okay, so you can see that's how they calculate. 72 minus 2.680 times 1.15. So you get 68.941. Then plus get 75.059. So you say we can be 99% confidence that the population mean will be between 68.941 and 75.059. It's very straightforward. So just make sure only thing you may have a trouble is put the T of 10 there. Otherwise, and make sure you got the correct T critical. Because if you got the wrong one, then the whole thing will be wrong. You can be work so hard, but ended the result is wrong. Okay? Okay? Very easy. Nothing hard. Okay, any question before I move to the next question? So this one is two sample t-tests, independent t. Okay. So their study about when you solve the problem. Okay. If one is you give the test and then give them mark. Okay. Tell them it's wrong so they can fix right away or without any mark. Okay. And then they want to see the two score like this. Okay. They are cat with remark or cat is a law. And this is two groups and they are independent. Right? So if you do this, actually this question have you go from scratch. Okay, so let's work together. How do we do the hypothesis? How do you do the hypothesis? I think we are going to do, okay, they ask us to conduct two-tailed test use alpha level 0.05. Okay, so what's your hypothesis?
So H0MD is equal.
Is this empty?
I don't know.
What's this? It's a two group. It's two group. It's two group.
So M1.
We are doing hypothesis, so you should say mu.
Yeah. Okay.
Mu1 equal mu2, right?
Yep.
Right?
Mm-hmm.
So that's how we do hypothesis, right? Okay, and then your alpha level 0.05. Your degree freedom equal what? We have how many? We have how many? 1, 2, 3, 4, 5, 6, 7. Right? So you have 7 plus 6 minus 2. So you have 11. Right? So you'll find the T critical is positive, negative, and whatever number we find. Right? Before you do the calculation. Right? Write down hypothesis. Okay? Because if here they say this, it means that you are not going to estimate yet. You are going to actually do your job from chapter 10. Okay? So let's see. I have here. Right? So I got a positive negative 2.201. Okay? Then you have to do your calculation, so that's why I time, plus them, time, and plus them. So you got all this information. Okay? And then we put into our formula. Okay? Okay? So because remember for independent T, the formula a little bit different, right? So you need the SS1 and you need SS2. Everybody still remember your independent T test? The square root of SS1 plus SS2, right? Remember the formula? SS1 plus SS2, N1 plus N2 minus 2, and then 1 minus divided by N1, right, and 2. That's second boy, right? The second brother, a little bit more complicated. So you have to do all this work. To SS1 to SS2. And then put in this formula. Right? And calculate. To get your SM1 minus M2. No, sorry, I should not say minus, I should say dash. SM1 dash M2. Okay? And you got this number. Right? Go back. That chapter 9 is chapter 9. Right? Okay. You have this. So far so good? You know what's going on, right? This is all frame, right? Okay. Then, I do the same thing. Okay, here. Okay. So I calculate T of 10. Okay. M1 minus M2 divided by S M1 dash M2. So I got a 3.28. Okay, so if you do the decision, 3.28, what's our critical value? I think it's
Positive, negative 2.201.
2.201. So are they good news, bad news? Are they good news, bad news? I think it's good news. Right? We should what? I think we should reject, right?
Yeah.
We should reject.
Because you're saying the higher scores are better.
Yeah, higher
And
is
the T
better.
obtained is higher than the critical. So,
Yeah.
Yeah.
Reject. Okay, but and then so P less than 0.05. So then you have to do effect size. Okay? And that's how you do effect size. And you got it. Okay. Okay, so this is pretty much the previous stuff. So should be no stranger there. Okay, so now let's go to our point estimate. Okay, so what's your point estimate? It's what? How do you get your point estimate for independent P? Your M1 subtract M2. Okay, remember that formula there? Okay, so actually it's mu1, you are point estimate for mu1 subtract mu2. So use M1 subtract M2 to estimate. So you remember we calculate the first mean score and the second mean score from the raw data. Okay, so you got this. Right, that's from our calculation. 41.86 subtract 32.83 equal 9.03. Okay, good so far? Okay, and then we do the confidence interval. Okay, so let's see what they ask us to do. They ask you to do, they are 95%. So that means alpha equal 0.05. And then degree of freedom, since we already got from here. So this will be the number we are going to use, 0.05, right? And then 2.201 we got here. Okay, so I didn't repeat that part. So just make sure you know where it is. Okay, so here, that's the formula, and that's the number, 2.201. Okay, so you subtract 2 mean score, you got 9.03. And then you subtract, and you time them, and you get this number. And then you plus them, you got the number. Okay? And so, what we say, so after get this, what do we say? What's the interpretation? What do we say? We will have how many percent of confidence? We will have a 95% confidence that the difference between mean should be between the number and the number. Okay, so you can see original your point estimate is 9.03. But then if you don't want to say, I assume population is 9.03. You give yourself a bigger range. You say, I'm 95% confident. Not between these two numbers. Okay, so you're less likely to make any error because you give a confidence interval. Okay, and then if we do 99%, then you have to go back to find the T critical from 0.01 to tail, and then plug into this formula. Okay, I think, do they have this? No. I think for this question, they just give you 95%. So this part is even easier, right? Okay? And then the next one, okay. The next one is about dependent T. Okay? And so let's say, again, about sleep disorder. Okay, so they have 26 people, okay, and have them during 2 weeks. What I put Q there? What's my Q? What? I think for a 2 weeks. Why I put Q there? Okay, for a 2 weeks period, the patient are then exposed 2 weeks. Okay, so they give it empty. They give it SSD. Okay, now give me your hypothesis. Everybody still remember how do we do hypothesis for this one? And this you will do two tail. What's your hypothesis? Everybody still remember how do we do hypothesis for dependent T? What's hypothesis?
Equals 0,
yeah,
not equal 0.
Yeah. Okay. Mu D equals 0 and mu T unequal 0. Okay, so that means I assume they are not different, but then I assume they are different. Okay. Then we put the alpha level 0.05 because this one they ask you to do they tell us a 0.05? Yeah, I think they asked you to do 0.05. Okay, so 0.05 and then 25, and you got this positive, negative, this. Okay. Then this just review. Okay. So you got SD. They give you SSD, so you can get SD. You get SMD. Then you get T of 10. Okay. So T 2.86. Compare with 2.060. Are we reject or fail to reject? We reject or fail to reject? 2.060. And we got a 2.86. It is good news, bad news? Is it good or bad? It's bad. It's good, right? Because the number is bigger. So actually you reject. You reject. Okay. T25, 2.86. Okay. So when we reject, we get effect size. And you got this number, 0.57. And we say a moderate effect. Okay. So far, so good. Okay. So of course the main point for this chapter is to do point estimate. So what's your point estimate? Okay, so make a point estimate. What's your point estimate? We say it's empty, right? And we got empty. We got empty. It's here, 1.2. They already give to you. Okay, so 1.2. 1.2, okay? 1.2. Then you have 95%. Okay, so that is use our alpha level already have. And T critical, and you subtract plus, and we say 95% confidence. And then next one is 99%. So you just change your degree freedom, no, degree freedom same, change your T critical. 99%. And that's 95%. Right? So you can see which number is even bigger range. 95% is 0.335 to 2.065. 99% you can get to 0.029 to 2.371. Your confidence level even bigger range. Okay? So depend on how many confidence interval you want to put. And then when we do SPSS, you need to change the percent, otherwise they give you the wrong confidence interval. If you 95, they usually set up 95. If you need a 99, you need to tell the SPSS, otherwise they will give you different confidence interval. See? This chapter kind of just your dessert. After the meal, you just get dessert, and it's very easy. Right? Okay. Any question before we go to your favorite SPSS flag?
With these, it seems like they're all two-tailed. Is that?
Yeah,
to
you
be
only can do
expected?
two tail.
Okay.
Yeah, because when you do confidence interval, you don't have two sides.
Okay.
So they're all two tails.
Okay.
Okay? You're never able to do one tail confidence interval. Very good. Any more questions? Okay, and you finished dessert? No, this is dessert, right? You full? So full? Your brain full?
It hurts.
Brain hurt.
All right.
Brain hurt.